today for this particular recording, we're gonna go through your quiz one. Primarily, you guys have the quiz one set B. I've shared to you some of the. I've already shared to you also the set A, so that it's a practice session for you guys. But hopefully, you guys can correct your mistakes and not be able to repeat them in the coming lessons and quizzes as well. One of the primary things I noticed that you guys have a mistake from is drawing your free body diagram. I'm not sure if it's just because that was taught to you that way, but knowing physics, it shouldn't change that much, and I'm pretty confident that that is not the right way to draw the free body diagram. Anyway, we'll go through that later. So let's just start muna with the exam, the true or false statement. So I can read muna instructions. You can read it on your own right dito. Mine is open elsewhere. So understand the problem well and follow the respective instructions for questions. You may use additional paper if the text sheet is not enough, and non-definitive answers to two decimal places. Some of you do not follow instructions really well. For the first one, it's pretty basic. It's true or false. The statement is correct, write true. Otherwise, write false on the space provided. So for the first one is pretty easy. Let's go for red. Yeah, para may iba. Okay. So true or false? Scalar quantities have magnitude and direction. The answer there is false. Just gonna double check if I'm recording. Yes, I am recording, including audio. Because the only quantities that have magnitude and direction are vectors. Scalars have magnitude, no direction, just like pressure. So true or false, a particle or body is in equilibrium if force components and resultant force equate to zero. The answer here is true. Number 3, true or false, the third law of motion refers to a particle at rest or moving at a constant velocity and will remain at the same rate unless subject by an unbalanced force. Some of you guys made some mistakes here. The Newton's third law, they are placed in order because they're not a suggestion there. Okay, the order at which Newton's law described, um, it's been there for a millennia na rin. So ever since the industrial age na, not millennia, over past few centuries. So this is not referring to the third law of motion because the third law of motion refers to the law of action and reaction. So this is false. And this one particularly describes the first law of motion. Okay? So for the fourth one, true or false, your mass on Earth is different when you are on the moon's surface. True or false? The statement is false. We're talking about mass. And mass is not equal to weight. Okay, maybe in some occasions, okay? It will only be different. It will only be different if we're talking about weight. Because weight is mass subjected to acceleration due to gravity. Sometimes written as such pag may conversion factor. Okay? Let's go to the next one. So for the next part here is conversion. You solve the following, you show your solution, you round off your final answer to two decimal places. Okay? I really want you guys to really follow your instructions done properly. Okay? So we're gonna use red. Okay? So round off final answers to two decimal places. Okay? Especially when applicable. And I want you to show yung solution. Now, some of you tinama ko na because you use your thermodynamic ways of conversion. Fine, you can do that as long as you show to me the proper cancellation. However, some of you don't even have a fraction, or you're placing the units at the wrong place in the fraction. You're placing the units to be canceled in the numerator. That's not the way to go in mathematics. That's not the way to go in algebra. Algebra is a way of writing equations just like a way of writing English in proper grammar. You have to follow its proper grammar, proper rules. So let's start with the number one. This is pretty much easy. Second squared, and we need to convert that to, let's go direct. We need to convert that to feet per second squared. So meters per second squared. So if you recall, 1 feet is about 0.3048 meters, and that should equate to, so you show me a cancel, and that should equate to 32,174 feet per second squared, which is 32.17. Since the instruction said round the final answers to two decimal places, and then finally boxing them accordingly. Number two, same thing, you write it down, 101,325 pascals. And you know pascals is also newtons per meter squared. So we're gonna need this to be converted to pound force per inch squared. That's easy. 101,325 Newton per meter squared. So we gotta go it one by one. So we need newtons to be given pound force, and we're gonna deal with meter squared later to inches. So that's, if you recall, 1 pound force is also 4.448 newtons. So that should cancel the newtons. That would leave pound force. The next one would be meter squared. Using my, I don't know the direct of meters to inches, but I do know 1 feet is 0.3048. So I did the longer route. So what I did was 0.3048 squared meter squared divided by 1 feet squared, and then 1 feet squared to 12 squared inches, and this would equal to, so cancel, 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 and we are left with pound force inch squared. This should equate to 14.696 pound force inch squared, or simply 14.70. And then box that. Now, before I proceed with number three, notice how I write the equation. I write them from left, right. The values and its corresponding units placed together, organized, and then I write the fractions in this fashion so that I know which units to be cancelled. So the numerator will cancel, this unit will be cancelled on the denominator part. And more importantly, the bar, okay? The separator. I don't know the official name for algebra when it comes to fraction and its bar, but let's just call it that way. Some of you forgot the bar. I mean, how are you supposed to cancel this one if you're placing it this way? What's this? You're just scribbling numbers. It doesn't mean anything. Even if you meant that it's supposed to be canceled, you have to translate that and communicate that properly by following your rules ng algebra and writing down equations properly, just like writing a proper English sentence. Okay? So most of you got this naman na, and it's a benefit of having the quiz on a much later time, right? Next time I'll try to do it differently, para at least fair for the first section who are able to solve this, who weren't able to solve this. So for number three, we gotta convert 200 pounds. And when we mention a man weighs 200 pounds, automatically this is force. That's weight, okay? That's not mass, unless it's specifically shown as pound mass, but it's not. It's pound force, and that's its default. That's its default. When we mention pound force, its default is being a force. Okay, it's a weight. Okay, and more often than not, we're using kilograms for mass naman. So unless it's specified directly by the problem, no. But if it's not, we assume it's a weight. It's a force. Okay, its mass is subjected by the force of gravity. Okay. So we're gonna convert it to slugs, and already gave the one slug to 14.59 conversion beat. Okay, so that applies to all. So for example, 200 pounds. So I'm gonna do this 200-pound force to slug. So all we have to do muna is convert that to kilograms and then kilograms to slug. Easy peasy. But remember, this is in pound force. So if we're gonna do it the traditional way, you gotta multiply the you gotta multiply the K conversion factor. So that's gonna be pound mass, pound force, feet second squared, then 32.174 feet per second squared, because that's the acceleration due to gravity. And if you're wondering where this came from, remember that weight is equals to mass G over K. Okay. All I did was just manipulate the formula. That would be M equals to weight times K over G. And with K over G, this is it. So what will happen here? Pound force will be cancelled. Feet squared and feet per second squared will be cancelled. All you have left is pound mass, which is now something we can comfortably convert, because 1 kilogram is 2.204 pound mass. A lot of you do not use more than a lot of you don't use only 2.2 for the pound mass. I encourage you guys to use more than 3 decimal places when you're trying to solve a problem, so that we have the same answers dito. Some of you pinagbigyan ko na. Okay, some of you already corrected it. And if you don't use this conversion factor, that's fine. That's fine. Okay, you arrive at the right equations naman. Pero next time, if I try to do it the right way, then, okay? And then from here, it's a matter of converting to one slug, 59 kilograms. And this should be around 6.22. And then next, this is for A. For B, I need the weight in newtons. That's a lot easier because we already know the convert. If you know the conversion of pound force to newtons, so that's 1 pound. Oh no, sorry, that's the one we need to cancel. So that will be 4.448 newtons divided by 1 pound force. So wait lang, I forgot to cancel here. Cancel this one as well. Yeah, leaving just only slug. So this one, pound force, and then your answer here will be around 889.6 newtons. Don't forget the box. And then for C, we need the kilograms. So it's a lot easier, because since if you solve A, you'll be able to solve for C. So again, that's 200. I would rather use yung given units rather than yung inferred units nyo, because we might have a difference in decimal places, you know. So, and that would affect your accuracy in answers, you know. So again, I do this. I'm not gonna write the units anyway. You know what? I'm just gonna write it anyway. So this is cancelled, times kilograms. No? So that's gonna be 1 kilogram per 2.204 pound mass. Cancel, and the mass I got was 90.74 kilograms box. And then finally for letter D, so weight in pounds when on moon, when the acceleration due to gravity on moon is 5.3. We already done this in your problem set, and the way we did it is by simply multiplying the fraction 200 pounds here. It's 5.3 feet per second squared divided by 32.174 feet per second squared, which should equal to 32.95 pounds. There we go. Yep. What happened? I'm still drawing. There we go. Okay. Okay. Don't forget this will be canceled. Cancel. So the way you see it here, I'm writing my solutions very clearly. Okay, as if writing one good sentence. Okay, using proper grammar and proper rules. The same way with writing English language, algebra has its own proper grammar and proper rules, including the usage of fractions. Please, if you know that you're lacking or you need to review your basic algebra and trigonometry, please do so on your own time. I will not be able to cover them as my job is to lecture you on statics. So the prerequisite for statics um, is your ENG 207A and of course your basic geometry and trigonometry. So if you know you're lacking there, there's a lot of resources online. You can refer to your old notes, find some old books. Okay? I can only cover as much in terms of reviewing. And yes, I noticed that there's a problem in terms of your trigonometry and recognizing signs and recognizing trigonometric functions. So, yeah. Okay, now to the solving part. If you're gonna read the problem, you're gonna read the instructions. Solve and show your solution steps. Okay, some of you did that. Some of you just left the papers completely blank. At least you did your best then. And then you round off the final answer to decimal places when applicable. Already gave the acceleration due to gravity in SI and in English. And then box final answers. Cancel and label units accordingly. And then finally, show your free body diagram and corresponding components. I think we have a misunderstanding here. I'm not so sure what you saw or what you know, but I've solved at least 20 problem sets in front of you, or pre-recorded or not, pre-recorded and live in face-to-face sessions. And as you can see, especially when you're reading the books as well, notice how the free body diagram are drawn. Do they draw the entire given? I don't think so, because a free body diagram is a diagram. It is used as a representation of where the forces are and its magnitude. Okay, so here's how we're gonna do it. I'm gonna draw first. So we're gonna do a recap. Maybe if I want so clear back then, I'm gonna be clear now. When I say a free body diagram, I just need to show the forces, where the force vectors are, and their magnitude. So let's use you know what? Let's use a gray color, and then this one is red. So we're gonna first draw a Cartesian plane, so to speak, your x and y axis. Luckily, I have a ruler here, so it's gonna be easy. Okay, so there we go. Only for that. Okay, and then go. Of course, you're gonna label them. This is gonna be x. This is gonna be y. All right. If you showed the FBD for two systems, that's fine. That's fine, because you can also show it this way. For example, this one at point C. So your FBD will look somehow like this. Oops, slightly bent. Okay, so yeah, there we go. And then somewhere like this. And then you probably label this as FCB, and then this is as FCD. But the thing is, we have this is a pulley, and pulleys translate forces. So your F1 is equals to FCD here, equals to FCB, and then it's also equal to FBA. So technically, this is F1, and this is F1 as well, at a particular angle phi, or any arbitrary angle there. Okay. Let's just put that in order. Let me just put that in order lang. Why am I not able to cancel this? Huh. No, I'm just gonna delete this. Okay, there we go. And then select this one. I'm gonna put it here. Yeah, there we go. And then select this one. So this is your FBD at point C. You can also draw the FBD at point B. So so as to save time, I'm just gonna copy and paste this one. It's not doing so well. Yeah, it's gonna copy and paste that one. Yeah, delete. Excuse me. Yes, so we're actually solving this live now. Although this is a pre-recorded session, I'm actually solving it without editing. Yeah. So what you see here, it is what it is. All right. So at point B, the FBD will look a little different now. So it's gonna be something like this. So we have force 2 here. So yeah, force 2. And then you have your force 1. And then your force 1. Okay, it's not the same. And then this is probably angle P. You don't know yet if they're the same. And then you also know that they have dimensions. So you can put that up. This is Y. And then this is 2. And this is X. Okay, good. For your set, uh, we're asked to find F1 and Y. Some of you missed that. We're supposed to look for Y. If given X is at 1.5 meters and F2 is at 1,000 newtons. Okay? So what do you do next once you've drawn your FPT? Okay, do not forget also this one. F1Y, F1Y, and then hindi kasha, lagay mo dito, F1X. So this one has F1Y, and then may F1X. So notice my free body diagram is composed of the axis, yung Cartesian plane natin, X and Y axis, kasi two-dimensional lang to. And then I indicated at what point so that hindi tayo malilito kung saan ako titingin. This is yung F1 na alam ko it's a pulley, so the forces should be translated all over. FCD, FCB, and FPA. So this is supposed to be F1 rin. And projected at an angle. Kung kailangan natin hanapin yung angle. Maybe hindi na. Maybe kailangan natin. I don't know. Malalaman natin pag in-establish natin yung equations ng equilibrium. Okay? And just like so, tignan mo, nilabel ko rin kung saan. Kung hindi kasha, just project it. Okay lang rin because that is what I need. Only the forces. I don't need you to draw the entire thing all over again. Why spend so much time when you're actually doing a quiz and something that's not very important at all? Okay? So that's how I want to see yung free body diagram. And I thought that was perfectly understood when I show my solutions to you when I upload the problem sets in your modules, the problem set in the modules I made in Canva, Okay, the next step here, of course, let's establish, since we know now our free body diagram and the forces. And the whole point of this, visually, you know what the forces are involved. You know that this only has a horizontal force, so the vertical force is de nada. There's nothing. Okay, so there's nothing there. You know what? Actually, let's just delete that thing. Okay, so the second part mo dito is establish equation equilibrium. And how do you do that? The summation of forces on y and x. So in this case, I do muna yung y because I want to show you something because it will make sense. Okay, so for y, this F2, for one reason, there's no forces involved. There's no horizontal forces. There's no vertical forces involved for force 2. So we're gonna talk about Fy lang. So here we got F1 sine P minus F1 sine theta. If we're gonna rearrange it, F1 sine P is F1 sine theta. And if you notice, oh wait, parehas sila F1 sine, which would mean theta phi is equals to theta. So now that's established. We can solve, let's establish naman yung x forces natin. Since parehas yung force, we know that parehas yung forces natin dito and parehas yung angle, that would mean we can equate F1 just like so. So F2 here, and then since parehas yung F1 here, if it, hindi natin ipapare. Alam natin parehas yung F1 dyan and parehas yung angle. Hindi natin alam pa. Cosine P minus F1 cosine theta equals 0. However, we know na angle P is also equal to angle theta. So we can rewrite the equation as F2 to F1 cosine theta. I just chose theta na lang because it looks nicer. In this case, we have two unknowns dito. Doesn't help na, okay, it helps that we establish that they have the same data, pero we have two unknowns. So we don't know yung theta dito, and we don't know yung F1. However, we can solve for cosine theta kasi we're given dimensions na 2 meters and yung x at 1.5 meters. Okay, so we can simply, so we establish an equation. Let's just call this equation 1. Okay, so solve for theta. So you can, you can project the drawing that you made here. So we have theta here. That's 2 meters, and this one is 1.5. So this is 1.5 meters here. So in this case, we can solve for theta by simply doing tangent theta 2 over x, where theta is tangent inverse of 2 over 1.5, which is which is 53.130 degrees, 53.13 degrees. And then from here, we can now, let's just call this our equation 2. And from here, we can now solve F1 by substituting theta there. So substitute equation 2 to 1. So we will have F1, F2, and then 2 cosine theta. And F2 is 1000 newtons, 2 cosine 53.13 degrees. F1 therefore is 833.3313 newtons, or then box your answer. But wait, there's more. So you already know yung one. You already know yung angle. So it's kind of easy to know na yung y. And in fact, it's one of the things that you're actually going to solve muna. So even without solving yung F1, you can actually solve for yung dimensions dito by using a trigonometric function. Since we know that phi is equals to theta, so solve for y. Let's put it here. So y natin, the other half naman. So this is x, this is y, and this is your phi, which is also equal to theta. So we're also able to use your tangent theta function. That's y over x. And y is simply 1.5 times tangent 53.13. And that should be equal to around 1.999. Yeah, 1.999 meters, or around 2 meters. And actually, even if you don't solve this, knowing that these are pulleys will give you a clue na eventually the distance here should be equal here. You see, the forces are the same here. Eh? So it's one way of doing your analysis there. Okay, so that's for item number 1. Now for item number 2, this is a bit complicated ng konti, but I think that some of you were able to get it naman under the time given. So I'm pretty proud of you guys in that, especially those sa mga nakapasa. For those who didn't get it, I suggest more practice. And most of you nagkamali dito, 60 degrees eh. So the clue here, so let's just use yung traditional black po and yung purple. Good. All right, so we're being asked to determine the tension developed in the cables below. Show your answers in, let's just use a different color dito. And red pa rin. Sige. We're gonna show yung final answers nyo in newtons. Some of you made a mistake and still left. Tama yung solution nyo overall. Tama partially yung free body diagram nyo, but you failed to convert it to newtons. So I still gave you some partial points doon because technically you did it the right way, but you just fall short sa dulo. Okay? So you know very well that we are being asked to find. In my case, I solve it. You label. It doesn't matter how you label it. So iba sa inyo, you label TAB, TAC, TAD. That's fine. I also, in my case, I label it as FAB, FAC, FAD. Okay, you're given the weight of the whatever weight is being suspended here at 300 pounds. If you convert this is about 1,000. Let me just do some calculation dito. So that's 300 times 4.448. Yeah, so that's 1,334.4 newtons. Okay? So what do you do here? There's a lot of force vectors dito. So, and if I taught you well, you would know na, okay, let's try to organize them muna. Okay? Let's try to draw yung free body diagram nito because that's one of the easiest naman. You can do it step by step rin naman pag di ka siya. So in this case, gagamit tayo ng something. Yeah, let's use yung white gray na to and yung classic ruler. So, pwede natin napantay dyan. Okay. And then, oops. Dito na tayo. Pwede natin pantay. There we go. That will be your x-axis. And then, patay natin dito all the way down here. That should be enough. And then finally, 80 degrees. All right, good. So, okay, good. So now we label them. So we know you what are the some of you draw the entire cable thing. So these are attached to a wall. But again, just like any free body diagram, I just need to know where the forces are and their components. So let's start with the easiest. You have one suspended weight Tito and it's projecting a force downward. That's your 300 pounds or your 1 point. That's why your 1,304.4 newtons. Okay. What else? You have one of the easiest running along the positive x-axis. Oh, by the way, some of you fail to label yung axis. Yung basta nyo kinonsider ko na yun, pero the next time na ginawa nyo yun, no point. So here you have, yeah, just like so. So just label that FAB. Okay, no need to put it FABX because it's already running along the positive x-axis. What else? Okay, so we have force AC. So force AC is a little trick here. So somewhere, let's use a different colored pen dito. Here. So it's somewhere here. Okay, not it's not going straight, pero sige. All right, let's do it again. No need to use the ruler. So we're saving time, right? Okay, this is your force AC, and then let's do other projections. So let's use this one. Actually, I'm more using yung green to. So we know it's somewhere here. Okay, and then from there, you reflect to me what are the forces dito. So we know that FAC has a y component, FACY. We know may x component, that's supposed to be a negative x component, FACX. And finally, you have FACZ. Just draw them properly next time. Ito naka-tablet lang ako eh. Okay, so this part gets, and then you can, let's just reflect lang yung angle inside. So we have a intersection dito, which you can also label as FAC prime. And you know this one is 60 degrees. And this one is 50 kasha. And let's use a different pen or just point an arrow dito that it is 30 degrees. Okay. And then finally, I'm just gonna do it as black. Okay, you have your FAD. Now, some of you got confused where the positioning is, but remember, you have angles dito, and that should already give you clue on nasaan eh. The fact it's 120 degrees from the x-axis, meaning it's all the way there, passing the z-axis. Okay, so somewhere here is your FAD. Let's use lang yung orange again. Let's use something brighter lang. Okay, so this is your 120 degrees. This is your 60 degrees, and this is your 45 degrees. However, most of you used yung 60 degrees for the y. And if you recall, these are technically you're already given yung coordinate direction angles ng force AB. You should have used this one. Okay. This one. You should have used this one because this one is 120 degrees. And that is the definition po nasaan yung FAD because coordinate direction angles are being measured from the tail ng vector or to the positive axis, to the positive axis. Okay, so that's x, positive y, and positive z axis. Okay, Then of course, pag hindi siya kasha, that's fine. That's fine. You can also project it somewhere else. Let's use again this one. So, kung na hindi siya kasha, so you can draw an arrow dito. Just to show you where it really is. So this is the, so there we go. Okay, so this is your FADY. This is your FADX. Then finally your FADZ. Okay. Now, if you fail to see this from this quadrant, try drawing it again from a different view. Pero I won't consider it because a free body diagram should be exposed, should be showing yung forces niya in all dimensions eh. So just imagine lang for academic sake lang. Essentially ito yun. So this is your Z, yung Y, ito yung negative X, X, negative Y. This is yung Z. So your ADs must be somehow here. So ito yung FAD mo. And then, of course, hindi na natin makikita kung nasaan si FADZ kasi it's along the Z axis. But makikita mo kung nasaan. This is your FADX. And this is your FADY. Okay, from a different angle. So this is from we could say top view. So top view. Hence, kung bakit hindi natin nakikita yung z-axis. Pero that's not necessary in terms of my problem solving. I'm fine with this to 3D. Okay? Okay. And this is not proper FBD then. Okay, time to solve. So, now that we know yung forces nila, we can now actually, do several things eh. If you are tawag dito, overwhelmed by the number of forces that we have here, we have a way of organizing things. And that's the purpose ng Cartesian vector form or notation, or what we call CVN. I just coined it CVN because it's a lot easier that way. So from here, we can actually organize them. And with FAB, it's one of the easiest to organize. Because it only has a positive x-axis. FABI 0J and 0K. And then that's newtons. The next one we can organize is FAD. Because FAD already has its coordinate direction angles. FAD here. You don't have to write yung positive or negative nila because the coordinate direction angles holds the signs already. So you can do FAD muna dito, FAD cosine 120 I, this is I, plus FAD cosine 120 degrees J, plus FAD cosine 45 K. Don't forget the units. Hindi nagkasya. So we're gonna, what? Yeah, there we go. So we just group them together. Okay, there we go. Next, for FAC, it's a little tricky because we still have to solve it. So how do we do that? For FAC, let's do it. Let's do it this way. For FAC, we have these angles already, so we can now determine that the components FAZ as FAC sine 60 degrees, FAC prime as FAC cosine 60 degrees, and then FACX is already know AC prime. That will be AC prime. X is here, so that's gonna be sine 30 degrees. And then FACY, FAC prime cosine 30 degrees. But since we're solving FAB, FAC, and FAD, there's no C prime here. So all you have to do that is just make sure that we have the same variable. So you can substitute the value of FAC prime here, which is FAC cosine 60, to here, which would make the new equation as FAC cosine 60 degrees sine 30 degrees, and then that's your ACX, and your ACY would be FAC cosine 60 cosine cosine my god cosine 30 degrees. And now from here we can actually set up F, yung Cartesian vector notation ng FAC. So that would be, actually you can simplify one of this. So if you simplify FAD here, you would have, it's gonna be negative zero point 0.5 FAD I negative FAD, wait, sorry, negative zero point 0.5 FAD J, and then positive 0.7071 FAD K. Okay. And now for FAC, all we have to do is just align them. So the X component is, we know it's negative here. So that's going to be, FAC is negative FAC cosine 60 degrees sine 30 degrees. And then Y component should be positive here. So that's going to be positive FAC cosine 60 degrees cosine 30 degrees. And then finally, positive FAC sine 60 degrees. Okay. And the beauty of this is that you know now which is the components. So from here, you know that these are the X components, the Y component, and then the Z components. Okay. So from here, so we can now establish our equation, equilibrium. So let's start with X components muna. Zero, so that, what do we have here? We have FAB, we got minus 0.5 FAD, 0.5, yeah, 0.5. Then we have minus FAC cosine the cosine 60 sine 30 degrees, and then equals to 0. That will be your equation 1. And then we have your equation for y, summation of 0 to y. So what are your y? So There's no component for FAB, no Y component, but we have for FAD, and we have a positive one for FAC. So that's gonna be FAC cosine 60 degrees, cosine 30 degrees minus FAD zero point 0.5 equals to 0. That's your equation 2. And finally, the z-axis. So summation of moment. Well, it's 2 years. Okay. So what do we have? So we have yung z, lahat ng z components. So FAB walang z component. FAD has a z component. So that's 0.70, 71 FAD. FAC has a z component, which is positive rin. So that's positive FAC sine 60. However, there's weight. So yun yung silbi ng equations of equilibrium. So we have here minus W na lang equals 0. And that is your equation 3. Okay? And then from here, it's just a matter of yung solving equations natin. You know? So let's solve one. And then solve with equation 2 to 3. So how do we do that? Ang ginawa ko, I just manipulated equation 2. We're going to use equation 1. There's too many unknowns. FAB, FAD, FAC. Too many unknowns. But with FAC and FAD, I can equate one with the other and substitute it sa equation 3. So what I did here was manipulated FAD. Okay, and then that will be equal to FAC cosine 60 degrees cosine 30 degrees divided by 0.5. And this now I substituted to equation 3, which would be, so here we are, so equation 3, that will be equal to FAC sine 60 plus 0.7071, so that's plus. Substituting FAD, which is FAC cosine 60 degrees cosine 30 degrees over 0.5 equals 1034.4 newtons. And then the isolating FAC is simply 1304.4 newtons divided by sine 60 plus 0.7071 times cosine 60 cosine 30.5. FAC is now equal to 902.6023 newtons, which is 902.60 newtons. And then you substitute FAC to equation 2 again, you would get FAD of 781.6765 newtons or 781.68 newtons. And then finally FAB, substitute the part values ng FAC and FAD, you would get 616.4888 newtons or 616.49 newtons. There we go. Of course, you have to show to me yung paano mo sinolve yung FAD and FAB. Now next, for equation 3, so for problem solving 3, we have this one. Okay, so The unstretched length of spring AB is 3 meters. If the block is held in equilibrium position shown, determine the mass of block D. So we need to find D. Okay, that's easy enough. So first things first, of course, you just write them down. So what you're supposed to find M at D. Okay, and you have a stretch length of AB. So this one, first one AB at here. A stretch length of AB at 3 meters. Unstretched. So that will be yung initial niya, AB. Not sure if that's a useful information, so let's just write it down. And of course, you have your corresponding Ks. So that's lang rin natin. KAC is 20 Newton per meter. KAB is 30 Newton per meter. Okay, and no need for this one. Okay, and then I guess the next step dito would be is free body diagram. So again, most of you still drew this one, Okay, and then the dimensions, But what I require, I don't mind if you put dimensions here, but what I do require is ang FBD. So first one is draw FBD. And what I require when you're drawing FBD is that you, okay, there we go. Okay, so you draw first the X and Y axis. Then you show the forces. So what are the forces? We're talking at point A here. So there's a force here. There's a, oh my God. There's a force rin dito. Let's just throw it dahan-dahan. Then of course there's a downward force dito. And we're gonna equate this W equals to FAD. Since if we're gonna draw the FBD here, it's gonna look like this. X and Y, and then we gotta put some drawing here. You would notice that this is gonna be FAD, and this is gonna be W, which is fine, by the way. And from here, weight is equals to mass times G. So it's a lot easier later. Okay. So from here you can now draw. We could you should properly label yung forces natin. So I labeled W equals FAD here because when you're setting up the equation, it's gonna look that way anyway. And then here is gonna be your force AB, and here is gonna be your force AC. Then you know very well that there's gonna be some uh, FAB has some X component, so FABX, then FABY, then FAC has also some X components, so FACY, FACX, FACY. Then of course you're also given some dimensions, so I believe from here, this is what, 3 meters? And this one is about 4. And this is about 3 meters. In fact, you can actually do a shortcut dito. You don't need to find, some of you find the angle, did find the angles, but that's fine. However, I just did this one. So alam ko na I can use yung slope triangle method natin so that I have triangles dito. So this one is 3 meters rin naman. So I can get yung hypotenuse nito, which is 3 square root of 2, and this one is 5. And if you wonder that, that will be simply, so here it's just simply 4 squared plus 3 squared. Then the other one is 3 squared plus 3 squared. This is 5. This is 3 squared root of 2. Okay? Okay, now that we know yung now we know our forces here and drawn our FPD, the next step is, of course, is to let's just do it properly to establish equation of equilibrium so that we can set up our equation. So how do we do that? Summation of force equals to 0. And then, so x forces. So what do we have? FABX. What is FABX? FABX is simply FAB times 4 over 5. Diba? And then minus FACX, where it is equals to FAC, that's gonna be 3 over 3 square root of 2, or 1 square root of 2, kasi magka-cancel yan. And that will be equal to 0. Hindi nagpalit. Anyway. And then we go with, sige, use that one. Summation of y, same thing. So that's gonna be FAB times 3 over 5 plus FAC is 3 square root of 2, cancel, minus W equals to 0. That's your equation 2. And then from here, we can substitute 1 to 2. So I manipulated equation 1. Wait lang. Let's do it properly. Okay. So from equation 1, FAB can be also represented into like this, 1 square root of 2. And then I can substitute this value entirely in equation 2. So that's going to be FAB 3 over 5 plus FAB 4 over 5 equals to W. And however, FAB, we don't know FAB yet here. Kasi kaya tayo binigyan nito. Good thing we know that the unstretched length of AB is 3 meters. And good thing that we were able to find the hypotenuse, or essentially that's the final stretch of AB at 5 meters. And we know yung spring constant niya at 30 Newton per meter. So in short, we can technically solve FAB using this one. And it's simply 30 Newton meter times 5 minus 3. And FAB is equal to 60 newtons. And with that, we can now solve for W. For W, is mass times G. So knowing that mass is equals to FAB, that's going to be 3 over 5 plus 4 over 5. This is newtons, and then divided by 9.8066 meters per second squared, wherein this is kilogram per meters per second squared, so that will cancel out. leaving you kilograms. So substituting that, that's gonna be 60 times 3 over fifth plus 4 over fifth divided by 9.8066. This should give you around 8.5657 kilograms, or roughly 8.57 kilograms. Okay. All right. And then finally, so that's how you solve the problem number 3. And then for problem number 4, so we have a flagpole here. Given yung forces natin at FB is equals to 700 newtons, FC at 560 newtons. We're being asked to determine the magnitude and coordinate direction angles of the resultant force acting on the flagpole. Okay. So if you're reading it correctly, we're here to determine the magnitude and the coordinate direction angles. So that's kind of like a lecture 2 problem, you know. So if you recall, so we're being asked to find FR and alpha, beta, and gamma, specifically the magnitude of FR. Pero we're given two forces. We're given the magnitudes FP at 700 newtons and FC at let's just call this FAB, just for sake, FAC. And this is 700 newtons and this is 560 newtons. And if you recall, the resultant force vector is the sum of all uh, vector forces. And in this case, we have two, so that's going to be FAB plus FAC. So meaning, we need to get this corresponding X, Y, Z components as well in order to get FR's corresponding FRX, FRY, and then FRZ. Okay, this is just for notes. Okay, I don't normally write this in a problem equation. So how do you do this first? Uh-huh. Of course, you draw first the FBD. So that you understand what you're dealing with dito. We're gonna be using a ruler again. There we go. So let's draw it here. Somewhere around here. And then let's draw our x-axis just like so. Oh, hindi siya pantay masyado, pero it's fine. For our purposes, it's okay. So I'm just gonna put it this way. Okay, and then just, put it vertically lang naman. Okay. There we go. And again, for the end time, I only need the free body diagram. I don't need you to draw the entire thing all over again. Okay, that should be enough. So, you know what? Actually, since I'm gonna be needing this anyway, always show ribbon, and then I'm gonna need to click this properly. Oh no! All right, let me just group them so that I don't. Okay, okay, and then there we go. So I can adjust this properly. So I'm gonna adjust this here. There. Okay. And now let's draw AC in a different color. Okay, let's go blue. All right. So we're given forces and the coordinates for their and relative to their axes dito. If you remember yung position vectors natin, this is a classic problem of having position vector and force vectors. So how do we deal with that muna? And we'll go on to that later. So in this case, let's draw yung FBD muna, just like so. So we're gonna draw yung dimensions natin. We know that this is 6 meters. I'm just gonna draw something arbitrary lang dito. So just 1, 2, 3, 4, 5. This is 0.6. That's gonna be our point A. Remember yung X natin. X, Y, Z. And then from here, we have also, that's gonna be, so we have 3 meters and 2 meters accordingly. So we have 1, 2, 3. Then here we got 2 meters rin. So 1, 2, just put 3 na lang dito. And then here we got 3 meters. 1, 2, 3. There we go. So then from there, for FAB, that's gonna be FAB is 2 meters from the positive axis and then 3 meters to the negative y-axis, so somewhere here. Okay, that's good. And then let's use the ruler there para lang safe tayo. And if you notice, this is going to the direction of F8, FAB. So this is from point A to point B. So this is a point B. Okay, so this is point B. There is force here. This is your force AB. I'm gonna write it just like so. Okay, force AB. And then from here, we're gonna write yung position vectors natin and their components. Kasi technically, we're gonna write yung position vector here as orange na lang. Wait lang. Let me do this properly. This is your force along this line is your force AB. But also along this line is your position vector AB and its components. So may magnitude siya dyan. So how do we do that now from here? Remember our game, we're gonna go from point A to point B. So we're starting from here down from here. So how do we do that? All we have to do lang is just project them properly. So I'm just gonna do this freehand na lang. So in this case, we know it's going 2 meters from the origin to the x-axis. So that's gonna be my Rx. Automatically, I know that's gonna be head minus tail. So that's gonna be 2 minus 0. That's gonna be 2 meters. So that's 2 meters. And then, of course, we're gonna go with the 3 meters down, so negative y-axis. So that's gonna be here. That's my ry, which is head minus tail. That's going to be -3 minus 0, -3 meters. And then, of course, from here, from 6 meters down to 0. So it's going to go all the way down. That's my rz, which is that's head minus tail. So it's going to be -6 meters. Okay. Right? Now we're going to use a different color naman for let's use purple. And then for force AC, it's gonna be 3 meters from the positive x-axis and then 2 meters from the positive y-axis. So it's gonna be somehow gonna stretch that parang ganito. Yeah, more or less nandito siya. More or less. And if we're gonna connect the dots, no. We gotta connect the dots, so it's gonna be somewhere like it's almost interfering with our flagpole doon, pero that's fine. Yeah, I think that should be good. And then we just trace that here. There we go. And here lies along our force AC, but also lies our RAC as well. So we'll just show kung paano yun. Ganun ulit. Point A to point C naman. So this is point C. And all we have to do lang is just follow it. In this case, medyo masikip na siya. So we can project it as just like so dito na lang sa ilalim. In this case, it's 3 meters from the positive x-axis. That's your RACX. That's 3 meters, positive 3 meters, and then positive. That's your RACY. That's 2 meters positive. Then of course you have also your. Okay, there we go. That's your RACZ, which is -6 meters. There we go. So just almost forgot that this is RABX, RABZ, then RABY. There we go. And then from here, you can actually formulate your unit vector equations na. So if you remember them, they're simply just like so, UAB. So we have position vectors running along collinearly with the forces dito. If you recall, FAB is also FAB times UAB, or unit vector pala, yeah. And whereby UAB is also FAB RAB over R, magnitude ng position vector na yan. Hence why we're determining it. So in this case, this will be FAB is 700 newtons multiplied by so that's 2I, that's minus 3J, and then minus 6 K over the square root of 2 squared plus -3 squared plus -6 squared. And this should give you about FAB into this is gonna be 7, so that's gonna give you 200 I minus 300 J minus 600 K. These are newtons. Okay, let's just place this equation properly lang. Right. Control G. Yeah, there we go. And then with FAC, ganun rin. FAC times UAC, where it is FAC times RAC, position vector over RAC magnitude. And if you recall, the magnitude of position vector is simply x squared plus y squared plus z squared. So this is equals to 560 multiplied by, we're gonna use this one so that you don't get confused. If you get confused, you can just label them just like so. So kunwari ganyan, RACX, RACY, RAC, say, lalagay nyo siya dito para sana hindi yung 3 meters, 2 meters, negative 6 meters. So, okay. So, that means this 3I, positive 2K, minus 6K. And some of you nagkamali lang dito. And then, of course, this is just 3 squared plus 2 squared plus negative 6 squared. And FAC is equals to 240I plus 160J minus 480K and newtons. Okay, and then from there, we just simply add this one algebraically to get FR. And FR is simply FAB plus FAC, which is equals to 440I minus 140K and then minus 1080. Sorry, this is J, sorry. J and then 1080K newtons. And then from here, these are your respective FRX, FRY, then FRZ. Some of you hanggang dito lang umabot, sayang. So it's just simply the square root ng FRX, FRY plus FRZ, which is equal to 1.1, actually 1,174.5637 newtons. And then from here, since you know already this one, all you have to do is to get the angles is just simply use yung formula ng coordinate direction angles, which is, if you recall, cosine alpha is FRX over FR. Cosine beta is FRY over FR, or magnitude. Cosine gamma is FRZ over FR. And just getting the inverse of this, just going to show 1. So that's going to be cosine inverse FRX over FR will give you 68 degrees. Then beta will give you 96.85 degrees. And then gamma will give you 156.85 degrees. In this case, this is going to be ganyan lang. And that's the final answer. Yep. Okay. That's a lot to take in. But if you have any questions, feel free to visit me during consultation hours or send me an email. Now, if you have any errors, put things checking. If you feel that hey, you deserve a point, come visit me in my office during office hours, and we can talk during class as well. After prelims, we'll be starting a new lesson called Force System Resultants. I hope you guys been reading. I hope you guys been reading about moments, torque, uh, couples of moments, especially the cross product. So dot product is a lot easier to compare to cross product because with cross product, you'll be gonna be dealing with matrices. Okay, and with that, let me just draw. No. And with that, good luck on your prelims. And remember, it's about the quality of study rather than the quantity of it. If you feel tired, go take some nap, and then study afterwards. Make sure magpagising kayo. I was also a student once, but right now you have the advantage of stamina. So it's all about you wanting to pass and at the same time um, knowing full well what the consequences are for not passing. And if you fully understand that, then you just go over the lesson, do your best. When you're tired, take a rest, take a nap, then go it over again. You deal as an engineer or as future engineers, you're going to be dealing with a lot of problems. And what's very important with dealing with multitude and variable problems is dealing them one problem at a time and compartmentalizing them. Okay? So good luck and see you around campus.